To get you ready for the quiz this week, I'm going to go over the handout problems because there will be a problem like one of these on the quiz. I would strongly recommend that you read the definitions in the book under the chapter and make sure you go through the section review questions that I have assigned, because quiz questions can come from that as well. That said, let's move to the first one here. The question is the following. A toaster oven is plugged into an outlet that provides a voltage difference of 120 volts. So V is 120 volts. And what is the power the oven uses if the current's 10 amps? So I is common for amperage or current, and it's 10 amps. And if you remember from your book that power is equal to the voltage times the current. So power is going to equal 120 in this case times 10, or 1200 watts, which sounds like a lot, but actually it's not. These ovens frequently will pull that kind of power. The second one says a flashlight bulb uses 2.4 watts of power at a current of 0.8 amps. What is the voltage difference? Well, the same equation here, this is number one, the same equation, that is power is equal to voltage times amperage, but now we're looking at voltage. So voltage is going to equal power divided by amperage, and that's 2.4 divided by 0.8, 0.8, and so that's going to, if you do the division here, that's going to be 3.0 volts. Number 3. Calculate the voltage difference in a circuit with a resistance of 25 ohms if the current is 0.5. Now, to do this problem, we have to use Ohm's law. And Ohm's law states that the voltage is equal to the amperage times the resistance. And so in this case, we have a voltage of 25 ohms and an amperage of 0.5. And so the voltage here is going to equal 12.5, or half of 25. And to the significant figures, it's going to be 13 volts. Or if you left it at 12.5, I wouldn't care. A toy car with a resistance of 20 ohms to a battery is hooked up to a battery with 3 volts. How much current flows through the car? Okay, same equation, V is equal to IR. But now we're going to solve for I. So I is equal to V over R. And we have a 3 volt battery and a 20 ohm resistor. So that's going to be basically 3 over 20, or 0.15 amps. Number 5. A calculator uses a 9 volt battery and draws 1/10 of an ohm, or 1/10 of an amp current. How much power does it use? We go back up here to power. Power is equal to V times I. In this case, 9 times 0.1, or 0.9 amp, or watts, excuse me. Number 6. The diagram pictured gives an equivalent, for the diagram pictured, give the equivalent resistance and current. Okay. Now, if you look at this diagram, remember there are 2 kinds of circuits. There are series circuits and there are parallel circuits. Well, actually 3 kinds, because you can mix these as we do in this one here. So a series circuit is like this. That is, they're lined up and there's only one path that the current can take. And in a series circuit, the equivalent resistance is equal to the resistance of the first resistor plus the resistance of the second resistor plus the resistance of the third resistor, and so forth. In a parallel, let's say this a little differently here. In a parallel situation, we can call this E. If the equivalent resistance is equal to 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc. So the 1 over the equivalent resistance is equal to that. So once you do this, find this answer, to get RE, you have to take the inverse of whatever you find for the answer here. So now let's go back to here. We have a 15 ohm resistor, a 10 ohm resistor, and a 6 ohm resistor. So the equivalent resistance is equal to 15 plus 10 plus 6, or 31 ohms. So that's the equivalent resistance in this series circuit. Then it says, what is the current? Well, you know that V is equal to IR in this situation, because the current is constant in a series. The current remains the same throughout, and so in this case they want to know what the current is. So we solve this equation for the current. I is equal to V over R. In this case it will be the equivalent, so that's going to be, and this is 10 volts, so we put 10 up here, and 31 ohms, and so it's approximately 0.3. I don't have my calculator with me here, so it's a little bit less than 1/3 being 0.33333, so it's going to be about 0.3 amps. Now the next question basically says, if this were in parallel instead of series, what would the equivalent resistance be in the current? Well, first of all, let me draw you what that would look like. You would have a 10 volt power source, and then you'd have a resistor here and a resistor here. And you can see why these are called parallel, because they're parallel to each other. But the other way to identify parallel is to recognize that at any point the current could take more than one path. In this, there's only one path that the current can take. Well, as I said up here, 1 over RE is going to equal the sum of 1 over each one of these. So we have 1 over 6 plus 1 over 10 plus 1 over 15. And the least common denominator here is going to be 30. 6 goes into 35 times, plus 10 goes into 33 times, plus, and 5 goes into 30, or 15 goes into 32 times. If you add all that up, you get 10 over 30, and that equals 1 over RE. So RE is going to equal the inverse of that, which is 30 over 10, or 3 ohms. Then if we put that up here, I is going to equal 10 divided by 3, or 3.3333 amps. So the current here is going to be 3.3 amps, and the equivalent resistance is 3 ohms, whereas in series it's 31 ohms for equivalent resistance and 0.3 amps for the current. Let's take a look at number 8 here. For the diagram pictured below, give the equivalent resistance and the current. Now, this is a situation where you have what's called a combination circuit, or where you have both something in parallel and something in series. This resistance is in parallel with these two, or series with these two. These two are in parallel with each other. So what the simplest way to do this is draw a circle around what is simplified, either the parallel part or the series part. And since the parallel part is the one you have to start with, you'd start with that and you'd say, okay, what's the resistance if I were to change these two into one resistor? What would be the answer there? And you have 1 over the equivalent of that part right there is going to equal 1 over R1 plus 1 over R2. And so this is 6 ohms and this is 3 ohms, so 1 over RE is equal to 1 over 6 plus 1 over 3, which is equal to 3 over 6. 6 is the common, this would be 2 plus 1 is 3. So RE here is equal to 2 ohms, 6 over 3. Now that means you can redraw this like this. This is 6 volts, and you go up here and you have this resistance, which is 2 ohms, and you can change this whole thing into one resistor that is also 2 ohms. So now you have two ohm resistors in series, which means the equivalent resistance for those is going to equal 2 plus 2, or 4 ohms. So now you have a situation where the equivalent, if you were to change this, all 3 of these into one resistor, it would be a resistor of 4 ohms. And then the current is going to obey Ohm's law. So I is going to be V over RE, which in this case is going to be 6 divided by 4, which is 1.5 amps. So that's number 8. Number 9. 1200 watt hairdryer is plugged into a 120 volt circuit. What is the current drawn by the hairdryer? Well, that goes back to our equation that says that power is equal to voltage times amperage. We're solving for amperage. We get power divided by voltage, which in this case is 1200 divided by 120, which is 10 amps. The last, number 10 here, the following diagram, find the equivalent resistance and total current. Now what we have here is 3 resistors all in parallel. And we remember that 1 over RE is equal to 1 over R1 plus 1 over R2 plus 1 over R3, which in this case is going to be 1 over 2 plus 1 over 3 plus 1 over 6. Now 6 is the least common multiple here. 2 goes into 6 3 times. 3 goes into 6 2 times. 6 goes into 6 1 time. And so you end up with 6 over 6. So RE is going to be 1 ohm. And then V is equal to IR. So I is equal to V divided by R, which is going to be 12 volts divided by 1 ohm, or 12 amp. And that's the current. So, again, I would urge you to study the section questions which focus on the definitions as well as these problems for the next quiz.